Now I've created a template to help us compare results across models. I'm going to do results from a couple of different KNN models with different variables, and then a couple of logistic regression models. And here is our confusion matrix on our validation set. And this allows us to see our true positives and so forth. In this sort of comparison template, what I've done is I have the actual yes and the actual no places where we can put our data. And this corresponds to, this is the actual yes and this is the actual no over here. We had 14 predicted yeses that were true positives, so I've put 14 in here. Then we also had 186 that were supposed to be negative that were actually positives. So these were the false negatives, so we'll put our 186 in here. All right, and then we need to get our true negatives, which there's a lot of in this data set. And we also need to get our 5 false positives over here as well. So if we look at this, then I have formulas set up in here to calculate the recall, the specificity, the precision, the F measure, and the percent error. And you can see that this 10.6% over here that is coming from a best K of 14 is about our 10.6%. So that's where that number's actually coming from. That's kind of checking that we've got the stuff entered in correctly. And so our best K on the validation set was 14, so we'll enter that in right here. All right, so this creates all of these things in percentages so that it's easy to compare models. Now the next model I'm going to do is I'm going to do a logistic regression model. I'm going to take the very same variables that we did with our KNN model, and we're going to do our we're going to do our fit model here to do our logistic regression. So we'll put our dependent variable in there, which is recognized as a logistic, should be done with logistic because it's a categorical variable. Put our validation data in, and then we're going to take all the rest of these input variables and add them here. The target level is yes, and then we're going to keep the dialog open because we're going to be playing with reducing and some of these variables that are not really helping us very much when we do this. And so we run this, and we can see that some of our variables are statistically significant and some are not. We can also look at our fit details. Here in our fit details, our misclassification rate is about 10.5% on our validation data. That's actually very similar to what we were getting with our KNN results. All right, now I'm going to look at our ROC curve and our confusion matrix. So if we look down here at the ROC curve, we have an area under the curve on the validation set of data of 0.6443. And if we look at the confusion matrix, we can look at our results down here as well. So what I'm going to do is put this information inside our, so I put all of our input variables here, and we're going to put in our true positives. So predicted yes and then is yes, so that's 28. All right, our false negatives, so that's our 172. Our true negatives, 1590. And then our 18 false positives. Now by looking across this template, we can see a number of things. Our error really is about the same as it was with KNN, but our F measure improved. And we can also see that our recall improved considerably and our precision really didn't improve. Let's think about what's going on here. In terms of our true positives, we did a better job of being able to find those. But then what happens is that we have also some things that we're predicting as positives that really aren't. So they're false positives. And so we have a higher number here. So here we gained in our recall, but we really lost out in our precision. We can also put in our area under the curve, which is 0.6443. So we'll put that in over here. You'll notice that there is no area under the curve and jump for K and N, so that's okay. So I've just marked these out as not something that we need to fill in. We'll get what we need basically by looking at how well we're doing with these other measures. Now what I'm going to do is I'm going to go back in and drop the things that really were not statistically helpful and see how well we do. So we've only left in then these variables that have a statistical significant relationship with the outcome variable, and we're going to see how well we do and if our error stays the same, gets worse, or gets better. So we'll run this now. If we look at this and look at our fit details, it actually turns out that our misclassification rate is exactly the same. And so we really didn't give up anything in terms of our overall misclassification rate. Now we need to examine our ROC curve and our confusion matrix. So if we look here, it looks like we did exactly the same. So we were able to get rid of all those variables, and these are exact copies of what we had when we did logistic regression with all of the variables. So this is good evidence that we can have a simpler model with fewer variables, and we had just as good performance as when we had all of the input variables in there. All right, so this has been educational in terms of realizing that we don't need those insignificant variables. Our area under the curve actually went up a little bit. That's very small, but it went up a tiny bit. All right, so very comparable results here. And so our model is more simple. Now, having done that, it would be good to see if we drop the ones that we don't need, if we're able to use just these useful variables that logistic regression found useful, and see how K&N does with fewer variables. So now I'm going to go up to my Analyze, go back to my predictive modeling and my K nearest neighbors. And now we'll be selective. So we're going to put that in our, and then we'll put our loan in, our job, marital, and campaign. Right. Still using 15 as the maximum K, and then it chugs for a minute and gives us our results. So here are our results, and so it looks like a K of 13 was optimal here. So we'll put that in there. Our confusion matrix over here is different. So it looks like our true positives are 12. Our false negatives are 188. So we can see right here that we actually did worse in terms of how well we're doing with our yeses. And then our true negatives are 1605. And we have 3 false positives. All right, and this is a good example here where our error in all of these 4 cases really didn't change very much. Now we know that in these 2, these really didn't change very much. We just got rid of variables that weren't helping us. But this is interesting because our error stayed the same, and yet our overall performance really got worse. If you look at what we did here in terms of what we're really trying to find, which is true positives, we really lost ground in terms of giving up about 16 of the true positives. So that actually got worse. But we did really well, or did a bit better, at finding the true negatives. So by getting rid of some of these other variables, K&N actually was not able to use that information, and it did not do as well here as when it did here. It went down just a little bit. But overall, K&N is not doing as well in this particular data set as logistic regression. Logistic regression had better recall, but it actually got a bit worse precision. So this is a good example of using a template to kind of compare results across a number of different models, and I have you do a very similar process in your homework